Welcome back to the Docker series. In Lesson 01, you ran nginx with a single command and it just worked. Today, we're going to find out why. The answer is images, how they're pulled, how they're tagged, and most importantly, how they're built from layers. Once layers click, you'll understand roughly 80% of how Docker actually behaves under the hood. Here's the roadmap, 4 skills, in order. First, you'll learn to read an image name like a sentence. Registry, user, repo, tag. So something like nginx 1.25 alpine actually means something. Then the 3 commands that cover the whole image lifecycle. Pull, list, remove. Same shape as apt on Linux. After that, the big one. Layers, and why your second pull feels instant. And finally, how to reclaim disk space before your laptop fills up. Trust me, that's a first-month skill. So let's start with that first skill, reading the name. Every image name has 4 parts: registry, user or org, repo, and tag. Take docker.io library nginx 1.25 alpine, that's where it lives, who published it, the program itself, and the version. Now here's the nice part, most of those have defaults. Skip the registry, you get Docker Hub. Skip the user, you get library, the official images. Skip the tag, you get latest. That's why typing just nginx actually works. It quietly expands to docker.io library nginx latest. Now that you can read an image name, you only need 3 commands to manage every image on your machine. It's the same shape as apt on Linux. Pull to download, images to list, RMI to remove. Pull is smart. If the image is already cached, it returns instantly. Images shows everything on disk running or not. And RMI cleans up, as long as no container is still using it. That's the whole loop. So why is pull so fast the second time around? Because images aren't single files. They're stacks of read-only layers. Look at the left. Your app sits on top of npm install, which sits on the node runtime, which sits on Alpine. Now the magic on the right, when you pull Python first and then node, Docker sees Alpine is already on disk and skips it. Same base layer, downloaded once, shared forever. That's the secret. Now, about those layers you're pulling, how do you actually ask for a specific one? Through tags. And here's where beginners get burned. Latest isn't a version number. It's just a label, and labels move. The nginx, latest you build against today, might be a completely different image 6 months from now. So skip the roulette on the left. Pin a real version like nginx 1.25.3 alpine, and your build stays the same build forever. Pin your versions, pull your images, run your containers, and a month later, Docker's quietly eating 50 gigs of your disk. Start with Docker system df. It reads like a sentence. Here's what's on disk and here's what you can reclaim. Then pick your cleanup level. Docker image prune is gentle, just dangling layers. Add A to clear everything unused. Docker system prune goes further, sweeping stopped containers too. And the nuclear option, A volumes, wipes it all, volumes included. Use that one carefully. Volumes are where your data lives. Now for 6 small habits that pay off big. Pipe Docker images, queue into xargs Docker RMI when you need a clean slate. Docker inspect gives you the full metadata story. Layers, env, labels. Docker history shows how an image was built, layer by layer. Docker tag renames for your registry before a push. Docker save bundles an image into a tarball for air-gapped servers. And platform Linux AMD 64 on a pull saves M-series Mac users from the classic "why won't this run" moment. Here's everything from this lesson on one screen. 12 commands covering the full image lifecycle. Pull and tag on the left, list and inspect on the right, and the housekeeping commands. Prune, save, load, along the bottom. Screenshot this one. It's the reference you'll come back to whenever muscle memory hasn't quite kicked in yet. Now that you know the model, here are 5 traps that catch nearly every junior. Treating latest as a version, it isn't. It's just a moving label. Skipping the Alpine variant and pulling a gigabyte when you needed 100 megs. Trying to remove an image while a container still depends on it. Forgetting that production tags update silently behind your back. And ignoring disk usage until Docker has quietly eaten 50 gigabytes. Each one comes from confused expectations. And you've already moved past that. Time to make this real with 3 quick exercises. First, pull both Nginx latest and Nginx 125 Alpine, then run Docker images and compare. You'll see the Alpine variant come in roughly 10 times smaller. Second, run Docker history on that Alpine image and read the created by column to watch the Docker file reconstruct itself, layer by layer. And third, run Docker system df, then Docker image prune-a, then df again, and see exactly how much space you just reclaimed. And that's lesson 2 in the bag. You now understand image names, pulling and removing, the layer model that powers caching, and how to clean up safely, which honestly is most of what makes Docker feel magical day to day. Next up in lesson 3, we put it all to work. Your first real Nginx container, with port mapping, proper naming, and a restart policy. The whole flow end to end. See you there.